Okay. So can you all see my screen?
Yes, yes.
Okay, so in this session we'll be exploring first the transformer library of Hugging Face. So using this we can do transfer learning with multiple models such as BERT, OpenAI, and all those we discussed earlier. So Hugging Face is an organization which and open sources the models and where you can share your models and use fine-tuned models of others as well as data sets, right? So in this session we'll be covering like some methods of Hugging Face API and how you can fine tune and use the pre-trained models to do your tasks. So do some like classical NLP tasks such as classification, summarization, and question answering. And based on it, you will be having an assignment which you will be submitting at the end of this week. Okay. So again, Face API is one of those APIs uh, which provides us methods to use large language models, right? So yeah, so in this session, we'll be using some of the BERT based models. BERT, BERT. We discussed it earlier in the slides. So yeah, we'll be using some of those models in this session. Okay. So I'll be going through the code and I hope you all get along with it. So as you can see, like it's a bit important kind of session. So this is what actually happens in the most of the organizations these days. So it's more practical approach to NLP, right? In the current context. So if you know someone who is still missing in the meet, you can call him to let him know that he's missing something important and also as well as ratification. So if you know someone is your friend, who's enrolled in the project, you can call him right now. I will again wait for 2 more minutes in that case. So I'll be starting now. Okay. So first we install the libraries. So this is the transformer library from Hugging Face and data sets from Hugging Face as well. So we'll do the installation of these two libraries. Then we do necessary imports. So all the operator, pandas, TensorFlow, and from transformers we import first the auto tokenizer. Second is pipeline. And third is the question answering model. Right. So this is one of the models, and these two are something important. We'll discuss it later, right? Their actual uses, right? So first the pipeline. So for anything you need, you're not getting like in this notebook. I'll share it at the end of the session. So you can just Google that specific term. So like this is pipeline here, right? I'll just Google pipeline Hugging Face, right? So you can find out like what does this method or this class do. So there are multiple things you can do using pipeline class. So you can import a test classification model. You can import a robota model, which is a large language model. You can do like summarization models import, and you can do question answering model import. So using pipeline you can import multiple models, right? So for example, you imported a text classification model, right? So we do the import here. Then based on a sentence, you try to find the sentiment of the sentence, right? Whether it is giving a positive vibe or a negative vibe. So, so as you can see, like if you read this sentence, Alice was excited to go to the island, but it didn't uh, live up to the hype, right? So there is a negative sentiment to this sentence, right? So you can see like it gives a negative sentiment. Okay, admit. Uh, Here is one more example for it, right? So as you can see, the he Bob isn't that bad in that situation, so there is a positive sentiment to this sentence, right? So yeah, you can see that it gives us a positive label, right? So if you guys have any doubt, you can just stop me in between, right? So here's another model. So you import a summarization model here, and right, summarizer is your summarization model. So here is a text, basically a paragraph. So it's about something related to chess. So we ask our summarizer model to summarize this text. So it gives us this output, which is smaller than the original one and summarizes the uh, about text. If you can see the text, it'll give you some time to read this text. Right? As you can see, like based on the pipeline model, it summarizes the your paragraph. Right. Third one is your question answering task. So you import a question answering model, assign it to the QA variable, and then in question answering task you have a context and a question, and you try to answer it based on the context. So here is your context. This is about the Hugging Face, like what exactly is the Hugging Face, and then you ask the question, who are the Hugging Face founders? Then it correctly answers these three names, right? Clement and all these three names, right? So another answer, like what does Hugging Face do? So they developed a chatbot app targeted at teenagers. So they developed a chatbot app targeted at teenagers. So as you can see, it extracts the part of uh, context to give your answers. As you can see, like it's exactly the same as here, right? Commas and all. So basically, in a question answering model, you are extracting a part of your text uh, to give the answers, right? Without any modifications, without any human like input. Not similar to what ChatGPT does, right? Okay. So other thing you can do is do named entity recognition, so NER, entity recognition, right? So you import a model for that, word based NER. So here you try to uh, assign entity like, oh, what is that entity? What could be that entity? So here is your sentence. So there are some entities this model finds. So first one is red. Then there is some like MO and D. So it there are there is there is a scope of error, right? Then third one is Microsoft. So you can see it assign it to like organization entity. Then OpenAI it assigns as international organization kind of entity. So you can see this is your NER, right? So now uh, we'll try to do fine tuning. Fine tuning is basically uh, using a pre-trained model to train on your specific tasks, right? So I think Aniket will take over now.
Okay, okay. Yeah, yeah. Wait, I'm just sharing the screen.
Okay, I will start.
Is it visible?
Huh.
Okay, give me a minute. Okay. So now we'll be working on fine tuning a. Okay. It's going down a bit sometimes. Okay. So first of all, we'll be using a data set that is squad, which contains some question and answers. We'll be working on fine tuning a model based on question and answering some stuff. For example, like I want a location from a text. For example, the text says that Sarah goes to so and so place, right? Say the Marine Blue Hotel. And my question is, where does Sarah go? Where Sarah go last night? And the model has to extract this certain information from that. From the text. Although the transformers can extract that text on their own, but say we have some style for extracting that, right? Like we only want the name of the place, or we want a whole sentence with that. So we can fine tune the model according to that. So yeah, for this part, we'll be using this data set that is Squad, and this contains this is a basically a dictionary. You can see it contains various features like the ID, the title, the context. But that is the text that we'll be getting to train on the question and the answer part as well. So basically, this is, for example, when you train on data sets like machine learning data sets, we have two variables, right? The x variable and the y variable that we train on. So this whole becomes the x variable for us, and this is the y variable that we basically that we have the label value, right? And okay, so here are some examples from that same data set that we have. You can see that if you want. Okay, so yeah, we'll be the model that we'll be fine tuning is this distilled robot database, and this is basically a modification of what we know as BERT model, and basically better version of the BERT model, that is a robot database. This and this model is basically what we say as a distilled model from distilled model of trained from this, which is, I mean, you know, but trained on something less and using a less rigorous method. So yeah, this is an and what we say, a small memory, small storage model for us that replicates the same thing as Bird in a less complex manner. Yes, and yeah, so first of all, we'll be having to the data set that we have, this complete raw data set. We'll have to find basically pre-process it, and the pre-processing steps involves two things majorly that will be coming on while we go on in the code base, right? Okay, so first of all, this is basic thing like we here's a sentence, and a tokenizer that we imported earlier can encode it in numerical vectors, right? This you should already know by now, and this tokenizer is itself imported earlier in the code, right? Okay, and yeah, also yeah, one more thing that we have. One more thing is the tension mask, which we do not use right now, but yeah, just look into it. This as well, right? Okay, now we have basically to yeah. I mean, this is converting it back, just decoding the same thing. from in basically encoding the tokens and decoding the tokens. And this G something that you see here is nothing. It's just the space character that we have before each question, and this displays that the sentence begins, and this slashes displays that the sentence ends. This all things that you see here, this G dot and this space begin and space ends, these all things are specific to this tokenizer that we have, where we imported the tokenizer is this. Okay, yeah, one more thing. This auto tokenizer that we imported earlier, this actually has a wait. I'm audible, right, for all this stuff.
Yeah, yeah, yeah.
Okay, so the auto tokenizer that is present here. Where did it go? Shit. Just a minute. Yeah, what this auto tokenizer does is whatever model that you have, it gives a suitable tokenizer for it from, I mean, the library itself imported earlier. So it gives a suitable tokenizer for that model, right? For tokenizing the words that it has. Okay, and now we proceed further in this. Okay, for example, how will we? Let's see how will we going on to pre-processing the sentence that we have, sentence, the context and the questions that we have. So, for example, consider this context that we have. Sarah went to the Mirthless Cafe last night to meet a friend, and the question was, where did Sarah go? Okay, and these are the answers, right? This is the y variable that we have, the real value of the label, the Mirthless Cafe, and the answer starts at the character number 14 in this whole context, right? Okay, now this is how we can this is yeah so this is basically a view of we'll be storing the question and context together. Okay, this together question and context is our x variable. Okay, consider that. And this is how we convert the whole question and context together into a into the x variables that we have, that we'll be training on, fine tuning on. Okay, and this is how we decode it further for each. I mean, each words will be separated, right, by tokenizers. But here comes the main thing. Okay, suppose we have a model. We have a very long context for us. So our model does not is not necessarily able to train on that whole long context, or say our because that will, I mean, require a hugely complex model, and suppose we are not able to train that either in our system, because even the Google offers I mean, for the free time that we have, for the free usage that we have, the GPU is limited as well, and all the other resources as well. So say we are not able to train on that, what we can do for that thing is divide the sentence into various parts. Okay, and how we'll be doing that is we'll be taking a sliding window. Say suppose you have a maximum character length of 15 that you want. Okay, for each sentence that we'll be training on. So what we can do is we can keep a sliding window of 15. Say first 15 comes till here. Okay, and we'll keep on sliding this window from with a I mean with the stride of one word. So first we'll start from Sarah and take 15 words. Then we'll start from went and take 15 words. Then we'll start from to and take 15 words, and so on and so on. Right? We are doing all this to, I mean, save our what we know as GPU memory as well, and as well as I mean, not requiring a huge time on training and stuff, right? Okay, and this is basically how we encode and decode this stuff. This is not important right now. Okay. Mm, okay. Yeah. Also, one more thing. We'll be now having something known as mm, yes, max length that we said earlier. This was set to 15. Yeah. So now our tokenizer just had this single thing that was. This is was in a pain. Shit. Give me a minute. Okay. Earlier, our tokenizer didn't have anything else. It just, I mean, encoded the whole sentence at once. Now, what we'll be having is the maximum length of 15 for each sentence, and then we'll be going on further. And what this will cause is it will have, now we'll have tokens of 15 length. You will be able to see multiple tokens, multiple sets of tokens, right? And yeah, they, all of length 15. So yeah, this is what is done, right? So you can see here how it is encoding it. So Sarah went to the mirth, and here is where F15 finishes, and then this method basically divides it into what we know as just three parts. Okay, like Sarah went to the mirth, and after that it is taking, and after meet it's taking. Okay, and the rest of the spaces are all filled with padding, right? Keep that in mind as well. So you will have to give padding equal to max length as well, this thing. Okay, and this is what we know as the simple thing. Okay, just dividing into continuous sentences of 15, 15, 15, and the other is filled with padding. This is a simple thing. And okay, and the stride also you can take from here, like if you want a 5 5 strides, shifting just 5 words each time, that could also be done. Okay, so this stride is something said by you. Now here in this sentence we have set a stride of 5. So you will be just doing this, and then you will be shifting five words further, and then you will be having a space and went to the mirthless, and then again shifting 5 words further, and then to the this and this and this and this and so on till we get. So you guys understand what is a stride, right? By now, you guys have. Oh shit! Just a minute. Oh shit.
Hmm?
Does anyone? I mean, are you all aware of what is the stride? Can someone comment?
I think he's having some internet problem. Just wait a minute.
Sorry, I was just the meeting just stuck off. Sorry for that. So my screen is visible, right?
Yeah, it is.
Hello.
Yeah, your screen is visible. Can you hear us? Hear me? क्या हुआ? मेरे वाले से कर दे, मेरे वाले से कर दे। Uh, okay, so Aniket is joining from my PC, so he'll be taking on now. Uh, can you all see the screen?
Yes,
Yeah, sure. Uh, हाँ था। Hmm. So I guess we were somewhere above now. We were a bit above.
So you were a bit above. Just give me a minute. Let me just share. Where we are. Okay, yeah, we completed this thing, right? Uh, with I mean, 15 length sentences continuous. Yeah. After that, hmm, will be yeah. We also did this stride thing, right? So what stride is basically it just gives us how much we'll jump after each step, right? So here we are jumping 5 characters after each step, and so after each say the Sara constitutes 5 character, and then so we go in the next sequence will start from this space bar that we have here, right? From this space and continue till 15 characters, and after that we'll again jump 5 characters, and then again it will start from this space bar that we have here, and then continue. So yeah, if we go on like this, we'll be having 10 sequences, so on. And for these each of these 10 sequences, we'll be having the input IDs that we see here, and we'll also be requiring some things, some offsets that we know as. Okay, yeah. First of all, this string is understood. Then we'll dividing on all of these into input sequences to train on. And another thing is, give me a minute. Where is it? Yeah. So for training, fine tuning these all models, we need another thing as well. That is where does the answer where our answer starts and where our answer ends. Okay. That is the y value of our training data set. Okay. And we get this.
So, and you saw here that in any question answering task, there is a context in a question, right? So, as you saw above, in the answers, we extract text from the context only, right? So, we need to know where does the answer starts, the position of starting of the answer and the length of the answer. We need these two parameters, right? So,
Yeah. So this is how now we tokenize. So we have a few more methods. That is the max length. We have already returning overflow tokens. We also have stride. We set it to 5 above, right? And return offset mappings. Yeah, this is something now we'll be doing. So what is offset mapping? It basically tells us the starting and ending of a word in each sequence. For example, here we have the starting from 0, and this word say it ends at 5, right? So 0 to 5, and this will be starting from 6 to 9, and I mean it goes on like that, right? Where will each word be starting and where will each word be ending? No, I mean this is going from 0 to 5, and then we have 7 to 11, and so on, so on, so on, right? So this is how we'll be having offset mappings as well. So we'll be also returning these offset mappings in our tokenizer, and these are all stored here. You can see these are the offset
these
mappings.
are all functions available in the tokenizer class of the transformer library. So this is something the Hugging Face provides to us, right? So
Yes. Okay, and after that, uh, yeah, these are all just I mean telling you whether the both the things are giving the same amount of input sequences, so you can check that. And yeah, another thing is hmm, okay, yeah, this is also the same thing, nothing to worry about this as well, just showing you some prints. And yeah, I mean, okay, also one more thing, when I talked about this starting of a sentence and ending of a sentence is using a bracket as characters, right? These are all denoted by zeros in here. So you will see here the sentence starts. If you see here how a sentence started is character as character, and this is denoted by 00. And then we have where did Sarah go last night, or whatever it is, a question mark and stuff. That is this whole character, this whole
where did
sentence
Sarah,
with where did Sarah go. This is represented like that. The 00 represents the starting of a sentence. 0 to 5 is where, and this is did. Okay, okay, yeah. and so on, so on, so on. So like this, we have 10 sequences, and each sequence is starting and ending characters of each word. We have that, right?
Also, these mappings are specific to the model we are using. So there may be another method for other specific tokenizers. So
Yeah,
it varies by tokenizer to tokenizer.
yeah. It varies model to model as well as tokenizer to tokenizer that we'll be having. So yeah, I mean, what we are basically doing by dividing these all characters, the main thing was to get these the mirthless cafe in one of these small input sequences, right? This helps us to, I mean, break down the whole complex process of searching in the whole sentence to searching in sliding windows sort of thing, if you could understand that. I mean, whenever you search in a big whole sentence, that creates a complex method by, I mean, there can be so many contexts involved in their relation of words. But when you search in small sentences, that eases the process of searching, as well as, I mean, the less text has to be analyzed each time. Okay.
Also, another thing is that your context may be too big for the model to analyze. So there is a limit of 5.2 tokens in the Hugging Face tokenizer. So if your context exceed that limit, in that case it is almost impossible to figure out the answer sometimes. So for that we use techniques such as sliding and the above ones Aniket talked about. So sliding window approach. So we do that so that our answers are present in the context without cutting the context.
Okay. So this is how it all is in. Okay. The input ID. I mean, like this, we are checking a few things. You will understand. I mean, just read it. This is not something of more importance. So the main thing that we are checking here is whether our answer lies in the first input sequence, the second input sequence, the third input sequence, the fourth, and so on, so on, so on. So we'll be having like where does the what is the starting point of starting position of this sentence, and what is the ending position of this sentence, and so on, for the second sentence, for the third sentence. Then we match it to the answer, that the y value that we have that is the where does our answer start. Our answer starts at the 14th character and ends at 14 plus whatever that we have, 14 plus length of answer. So we'll be searching, and we'll be getting out the getting out the sentence that we have. Say example, the third sentence I mean, involves our answer, the mirthless cafe. So we'll be getting out the third sentence, and this all will be figured out by the while doing the training part, and will be checked with the value that we have, the answer start and the length and the answer value. Yes, two things. Okay, and this is what is done here basically. This predicts the last character of the last character of the input sequence, and this is the first character of the input sequence that can be I mean, that can be extracted from the sequence IDs that we have while making the tokenizers. Just read this part as well. Yes, and after that, yeah, this is also basically the same thing. Just getting out which which input sequence contains the answer. And yeah, this is decoding. I think interesting here as well. This is the same thing again. Okay, yeah. So after all this process that we saw above, this is finally how we prepare a function for making I mean, pre-processing the whole data set, right? This is the tokenized example, I mean, the tokenizer that we have. Then also we are stripping down all the extra spaces that we have in between the words. This is done by strip basically. And after that, again, you have things like sequence ID. Yeah, okay. So this is sequence ID is index is the with, I mean, the sentence input sequence we are on, number of nth input sequence we are on. Yes, and yeah, I mean, then we have the sequence IDs. We are basically extracting all the things for an input sequence, the sequence IDs, the offset mappings, and this is our y value that we have. This is our x value that we have, and then we'll be going on in pre-processing the data set. I mean, the whole data that we have. We basically store where a sentence starts, where a sentence ends, the characters of the where the input sequence starts and input sequence ends in the whole context, and then we'll be returning those examples. Yeah, and after that, yeah, we'll be going on training it.
Yeah. So First, before going ahead, I'll summarize the entire process till now. So, start the fine tuning part. Okay, so I'll start again. So, first we imported our data, the squad dataset. It is a famous dataset trained on Wikipedia paragraphs and some questions prepared on them, right? So, uh, the dataset is in a form of a dictionary. So this function basically give you about training and validation split by itself. So you don't need to do it manually again, right? So the load dataset function does it itself, right? So this is your dataset. So there is a context. There is some big context. It will take time to load it. Uh, but there is some paragraph from Wikipedia and there are some questions and their answers are then stored here. So I think we'll wait for some time to load it here. Then until then we'll come back to it, right? So then we import our model, the digital robota model. So as you saw earlier, that BART is a model we talked about earlier. Uh, Sorry, digital BART is BART but smaller and faster. There's a technique called knowledge distillation, which is used to make prepare distilled bird from bird. Then Robota base is improved bird model. It was prepared by Facebook. Uh, so the distilled Robota base we are using. So better bird but faster bird. So basically distilled Robota base is that you can get it like that. So then we import tokenizer from the model. So each model have its specific tokenizer. So if you remember our transformer lecture, so tokenizer can vary model by model. So using the auto tokenizer class of Hugging Face library, uh, we import tokenizer for this specific model. Okay, so we got the tokenizer for digital robot ways. Then we tokenize our then we encode our some sentences and then we convert this sentence into it's into tokens, right? So this is your start token, this is your end token, right? The end of sentence and start of sentence. In between there are your tokens of the sentence. Where can I find a pizzeria? Question mark, right? So these are your encoded tokens, right? So in case of digital robot database, it splits the sentences with a starting one, starting as kind of thing, and an ending uh, as div, right? So and also for each space, it gives a G dot kind of symbol, right? It is specific to this tokenizer. It's not that important, just general knowledge kind of stuff. Okay. Uh, then we just then we encode our pair to tokenizer. So this is your question and token and answer. You feed them both to the tokenizer, right? To in when you are preparing a model, you'll feed them both by combining them into a sentence, as you saw below earlier, right? Then it's the same thing. So then again, there are two types of models in the Hugging Face library. Right? That's just no, that's just specific to the digital bird model. It's there isn't any reason for why does that come. It's for the space. Instead of space, we represent it with G dot. The tokenizer for digital bird does that. So there isn't any specific reason for that. Even if there is any, I am not aware of that. But as far as I know, it's just a uh, common thing done in the digital models, right?
Okay.
Okay, I hope that's clear. Okay. So again, there are two types of model in the transformer library. One is the Python implementation. Second is the second is the Rust implementation. Rust ones are faster. So by default, it's fast only. But we are just checking here using the assert sentence. So it's indeed the uh, fast tokenizer, right? So then the this is the question answering pair we are testing our model on, right? So this is the question, where did Sarah go? So you can see the mirthless cape is where the Sarah go. So then we tokenize both question and context here into to, to tokenize both of them together, right? Then it's the same thing. Now, in Roberta's case, as I told earlier, that 512 is the maximum limit of your token length, right? So assume if it was 15, our current sentence will exceed the limit, right? As you can see, when we tokenize them, the Sarah went to the Mirthless Cafe. For some reason, it tokenized both M and IRTH into different tokens. That's model specific. But because of that, our half hour sentence got truncated, right? We don't have the cafe and all that forward part, right? This part we don't have anymore, right? We lost this data while trying to tokenize. If our maximum length was 15, it's actually 512, but if it was 15, it would have truncated our data, right? So we don't want that, right? In many cases, your context may be much larger than 512 tokens, right? So for that, we use different techniques such as uh, uh, padding, striding, and all those Aniket talked about. Like striding is basically uh, splitting it into multiple parts. So if the stride is 5, you take 5 previous tokens as well, right? So using that, basically, we want to make sure that our answer is in one of the in answer is present in at least one single subsentence. So you can see that the Mathless Cafe is our answer, and it is present in this one subsentence, right? This is present in this one as well and this one as well, right? So there are at least some subsentences where our answer is fully present, and it's not splitted across different subsequences, right? So that's that thing. Now again we'll come to start position and end position. So we need start position and position of our answers to find out what is the actual answer from the context. So as I told multiple times earlier that our context, our answer is based on the context only, and the exact words from the context are provided as answer to our question answering model, right? So we need the start position in that context and the end position in that context, right? Or the length of the answer. There are three possibilities, right? Three. You can either have start position and length, or either or you can have start position and end position, right? So now this is all prepared, right? This is our X data here. Uh, Now the offset mapping Aniket talked about. Offset mapping gives you the start and end position of the any word. So you can see. Also the 0000 represents your uh, represents the clubbing of two sentences, right? So this is first sentence, this is second sentence. This is your question sentence, this is your answer sentence. So 00 gives you that. Double two times 00 gives you that. One times means the starting of the sentence, one time means ending of the sentence, right? So again, same thing. Yeah, I think it's just uh, these are all like not that important stuff. You can read it if you like when you provide the collab notebook. So okay, this is the prepared dataset part. Aniket covered it. So as you can see, we have both question and the context from the examples, and then we club them. Then we go one by one to each sequence, and then we try to store them one by one, right? Now is the training part. So this is our max length of the sequence. The stride we set as 100 and batch size 32. And then we have our prepared data set. Then there are some columns removed. We don't need these things anymore, right? Then there's a test, two part of data dictionary I talked earlier. So this is our trend set. This is our validation set. Now this is a we imported this model earlier, if you remember, right at the top. We imported Scripting auto tokenizer pipeline and this model, right? So we imported this model earlier, right? So this is our model for question answering task. Now, so until this, we prepared our data set. We did some pre-processing stuff. so that our results are much better than they will be without any processing. Now we imported the model. Now we'll be doing training and trying to getting the answer. So this is how we're giving our question and context. So we are clubbing them again together, question and context. This is our output. So train, we do the model. Based on the model, we found out, we provide input to our model, and based on it we find our outputs, right? Then we find the start position and end position based on the outputs, and based on that we'll try to decode that answer. So we'll get our answer in form of tokens only, and we then decode it using tokenizer and then provide our answer, right? So I think it's still, as of now, model is not trained, so we don't get any answer right now, right? So we are not getting the correct answer here. So the model is still getting trained. As you can see, the loss is continuously decreasing. It's taking too much time right now. Uh, so you can try to run it on your own, right? So right, so it's taking some time right now. It will take, I think, around 15
And when you train, guys train, so try to reduce the data set because it will take huge amount of time to train it on a big data set that we are doing right now.
Yeah. So I can't show the model working right now, but it should work in your case, right? It's taking some time to fit the model, right? So okay, so that was all about the fine tuning of the model. So now I will be telling about the assignment, right? So in this week you will be trying to work on a medical data set. So medical information data set. So assume I will be providing a JSON file. So these, so wait, I'll just show here. Okay, so these kind of things you will be your context, basically medical diagnostic. Based on it, you will be extracting stuff like what is the age of your patient, what allergies your patients are having, uh, what symptoms are they having, and what is their gender and all those stuff, right? So I will provide you dataset, and you are free to use any LLM API, Hugging Face, Haystack, OpenAI API, anything you wish, any model on the internet, right? You are free to use anything for it, and what you are expected is to get at least 60 percent of F1 score and exact match, right? So what are those? You just search on Google, you will find out. F1 score and exact match. I need at least 50 to 60%, right? So you are free to use any models, anything on the internet. You can just copy paste if you find anything. I will provide you a dataset. Uh, you need to do training, and based on the test dataset, you need to get at least 50 to 60% accuracy, right? So that is your assignment for this week, right? Uh, I will put it all in the group as well. Uh, are there any doubts? Okay, so again I'll repeat the assignment. You will use any model, and you will try to fine tune it using the data set I provide, and try to answer question based on it, right? So you are free to use any models on the internet, any code, anything you want, right? But at the end I need unique submissions as well as submissions with at least 50 to 60% F1 score and exact match, right? F1 score and exact match, right? So that is your task for this week. The deadline will be midnight of 9th. You have around 2 to 3 days, right? So it's not that big of task. If you are free to use anything on internet, I am giving a full freedom of that, but I need unique submissions. That uh, is a fact, right? So your submission will be judged first based on its uniqueness, second on your accuracy, right? uh, so based on that your score will be calculated for this assessment, right? I will put all this in the group as well. So yeah, if anyone have any doubts about it, can ask right now, or anything else about the project. If you don't have any doubts, you can just drop off the meet. uh, I will give the recording. So now I'll stop the recording.